Today we're going to continue with elimination. So remember, when we're dealing with elimination, we want to have our like terms lined up. We want to have one of the variables have opposites, so then we can add them up, it disappears, and then we can start solving. However, just like with graphing and substitution, there could be a result where we actually get no solution or infinitely many solutions, as well as, getting one solution where we would then actually find an ordered pair. So let's recap. When we have no solution, that happens when all the variables, sorry, my pen's being not great. All variables cancel out. And we have a false statement. So I'm going to give us an example. An example of a false statement would be something like 2 equals 0. Okay, obviously that's not true, so that means we would have no solution. We will have infinitely many solutions when all the variables cancel out and we have a true statement. So an example of a true statement would be something like -5 equals -5. Obviously, they're the same number. So yes, it's a true statement. Okay, so we're just going to continue practicing more by solving for elimination and then checking our solution, just knowing that now it's not just necessarily going to be that we get an ordered pair, which would be one solution, but we could potentially have no solution, or infinitely many. So when I'm looking at this first example, 3x minus 6y equals 18 and 5x plus 2y equals 6. I see that my like terms are nicely lined up. The x's are lined up, the y's are lined up, the equal signs are lined up, the numbers are lined up. Okay, but if I'm looking at the x's, I see a 3 and I see a 5. Those are not opposite. Then I look at the y's. We technically have a -6 and a +2. Those are not opposites either. So when we don't have opposites on either one, we have to then figure out, okay, well, what equation can we multiply by so then we're able to get opposites for one of the variables. So we want to look at the smaller variable. So 3 is smaller than 5. So then you're asking yourself, okay, can I multiply 3 times something to get 5? Our answer is no. So it's not going to really work with the x's. So then if I look at the y's, 2 is smaller than 6. 2, can I multiply something by 2 in order to get 6? And my answer is yes. Because the top number is -6, that means I want the bottom number to be +6. Since that 2 is already positive, that means I want to multiply the entire bottom equation by a +3. So I'm going to rewrite the top equation exactly how it is because we did not change that at all. But now that 3 is going to get multiplied by every single thing in that bottom equation. So 5x times 3 is going to give us 15x. 2y times 3 is going to give us a +6y. That equals 6 times 3, which is 18. Now that we have opposites in front of the y's, we can add up our equations and the y's will cancel out. So 3x plus 15x gives us 18x. The y's cancel out, so I'm not going to write y. It's going to equal 18 plus 18 is 36. I'm going to solve for x by dividing both sides of my equation by 18. And so I get a value of x to be 2. So if we solved for x, we have to now solve for y. So I'm going to go back to one of the equations. So if I go back to like the original equations up at the top, if I want to solve for y, I'd like to go back to where I have a positive y, so that would be the bottom equation. So the original bottom equation was 5x plus 2, but now, I'm sorry, I want to multiply 5 times 2 because I know that x is 2, plus 2y, that equals 6. Well, 5 times 2 is 10, plus 2y equals 6. Now I want to start solving for y. I've got two numbers on the same side as y. I want to move the number that is not connected first. So the opposite of a positive 10 would be a negative 10. So that gets rid of that. We still have the 2y. That equals 6 minus 10 is negative 4. Last step in order to get the y would be to divide both sides by 2. And we get y then to be negative 2. So because we have an x and a y value, that means that our solution is going to be the ordered pair. We put x first, followed by y. Now remember, the directions though say to check our solution. So I am going to go back and check. By going back to the original equations, I'll have 3 times 2 minus 6 times negative 2, and we're hoping that that's going to turn into 18. Well, 3 times 2 is 6. A negative 6 times a negative 2, a negative times a negative is going to make that a positive 12. And hopefully we're okay. 6 plus 12, that does check out. That gets us 18. So the top equation is good. The bottom equation, we're going to substitute in our numbers. So we have 5 times 2 plus 2 times negative 2, and we want to make sure that it equals 6. Well, 5 times 2 is 10. 2 times negative 2 is negative 4. 10 minus 4, that checks out. That gets us 6. So that's why we have one solution, and that solution is the ordered pair 2, negative 2. If we take a look at this second equation here, we've got 6x minus 4y equals 20. We also have negative 18x plus 12y equals negative 30. The x's are lined up nicely. The y's are lined up nicely. The equal signs are lined up nicely. The numbers are lined up nicely. So we don't have to do any rearranging. I want to see if I can add them up and have something disappear. Well, the x's, one's a 6 and one's a negative 18. Those are not opposites. That's not going to cancel. The y, we've got a negative 4 and we've got a positive 12. If I add them up, it's not going to turn to 0. It's not going to cancel out. So now that means that we have to multiply an equation by something so we can get opposites. Well, if I look at 6, can I multiply 6 times something to get 18? My answer is yes. I can multiply by 3. Because the bottom is a negative 18, I want the top to be a positive 18. So since 6 is positive, we want to multiply it by a positive 3 in order to make that happen. So I'm going to multiply every single thing in the top equation by positive 3. So 6x times 3 gives us that positive 18x. Negative 4y times 3 is going to give us a negative 12y. That's going to equal 20 times 3, which is 60. I get to leave the bottom equation as it is because we didn't multiply anything by that. And now that the x's are opposite, I'm going to add them together. Well, 18 minus 18, that goes away. If I look at the y's, negative 12y plus 12y. So negative 12 plus 12, that's also an opposite. That's going to disappear. So the whole entire left side disappears. That's why it just turns into 0. On the right side, 60 plus negative 30 or 60 minus 30, well, that's going to give us 20. Notice how all my variables disappeared and I have a false statement. 0 doesn't equal 20. So when I have all the variables disappear and I have a false statement, remember, that's one of my different types of solutions. That happens to fall under the top one here where it says no solution. The variables cancel out and we have a false statement. So that means we have no solution. And because we have no solution, there's no way for us to check our work, so we don't have to do that. So we're done. Moving on to this third problem, we've got 4x plus 8y equals negative 24. We also have negative 2x minus 4y equals 12. If we look, the x's are lined up nicely, y's are lined up nicely, equal signs are lined up nicely, numbers are lined up. If I look at the x's, they are not opposites, so I cannot cancel. 8 and negative 4, the y's, those are not opposites, so I cannot cancel. So that means that we have to think about changing one of the equations by multiplying. Negative 2 is smaller than 4 as far as the x's go. So I want to ask myself, can I multiply this negative 2 times something and turn it into 4? My answer is yes, I can. I can multiply this 2 by 2. And I want to keep it a negative. So because this 2 is already negative here, I need to multiply by a positive 2. Because the top is positive, I want to keep that bottom number negative. So I'm going to write the top equation as it is. We're not changing that. But because we're multiplying that bottom equation, every single thing's getting multiplied by 2. So negative 2x times 2 would give us a negative 4x. Negative 4y times 2 would give us a negative 8y. That equals 12 times 2, which is 24. Now that I have opposites in front of the x's, I can add up my terms. Notice that the negative 4 and positive 4 are going to cancel out. That 8 and the negative 8, those are going to cancel out. So everything on the left cancels. That makes it just 0. On the right side, negative 24 plus positive 24, well, that also cancels out. That turns to 0. So notice that all of my variables canceled, and we end up with a true statement. 0 does equal 0. So if we go back up, that is going to be the situation where we have infinitely many solutions. Notice once again, infinitely many, all variables cancel out, and we have a true statement. So we have infinitely many solutions. And so once again, we don't have a specific ordered pair for us to double check, so there's no need to check our work. So the only time we have to go back and check our work is if we have one solution where we actually get an ordered pair. If we ever get no solution or infinitely many, then we don't have to check afterward.